slanted line, 2 positive intercepts, and 1 triangle area can determine an exact coordinate. Today we will connect slope to the 2 legs of that triangle, solve for the y-intercept, and verify the result 3 different ways.
Here is the exact workbook prompt. A line with slope -2 has positive x and y-intercepts. The line and the coordinate axes enclose a triangle of area 36. What is the y-coordinate of the y-intercept?
This is a student-produced response, so there are no answer choices to test. We need one number. The givens are slope -2, 2 positive intercepts, and triangle area 36.
Picture the positive x-axis and positive y-axis as perpendicular legs. The line joins one positive point on each axis. Those 3 segments form a right triangle, even though the prompt does not draw one for us.
Let B be the y-coordinate of the y-intercept. Then the line crosses the vertical axis at 0, B, because the intercept is positive. We already know B is greater than 0.
A line with slope -2 and y-intercept b has slope-intercept form y equals -2x plus b. That equation contains both the known slope and the unknown height we want.
At the y-intercept, x is 0, so the equation gives y equals b that confirms the vertical leg of our coordinate triangle has length b.
At the x-intercept, y is 0. Set 0 equal to -2x plus b, move 2x to the other side and divide by 2. The x-intercept is b over 2.
The negative slope makes sense now. Starting at height b, the line falls 2 vertical units for every 1 horizontal unit. It therefore needs b over 2 horizontal units to reach height 0.
A common trap is to call the x-intercept 2b because the slope magnitude is 2. But a steeper downward line reaches the x-axis sooner, so the horizontal run must be half the vertical height, not twice it.
Now the coordinate axes give the right angle. The base is b over 2 and the height is b, so the triangle area is 1/2 times those 2 leg lengths.
Substitute the 2 legs into the area formula. 1/2 times b over 2 times b equals 36. Every factor comes directly from either the coordinate axes or the slope.
Multiplying the constants gives 1/4, and multiplying b by b gives b squared. So the equation simplifies to b squared over 4 equals 36.
Multiply both sides by 4. That isolates b squared and gives b squared equals 144.
Taking square roots produces 2 algebraic possibilities, b equals +12 or b equals -12. The equation alone does not choose between them.
Now use the condition that both intercepts are positive. A -b would put the y-intercept below the origin and the x-intercept at -6. That violates the prompt, so b must be +12.
If the y-intercept is 12, the x-intercept is b over 2, which is 6. Our 2 intercept points are 0, 12 and 6, 0.
Check the slope between those points. The vertical change is 0 minus 12, and the horizontal change is 6 minus 0. -12 over 6 equals -2, exactly as required.
Check the area next. 1/2 times base 6 times height 12 equals 3 times 12, or 36. The area condition also matches exactly.
And both coordinates are positive. The answer passes the slope check, the area check, and the location check. Independent checks make a student-produced response much safer.
There is another elegant route using intercept form. If A is the positive x-intercept and B is the positive y-intercept, the line can be written as x over a plus y over b equals 1.
Solve that equation for y. It becomes y equals -b over times x plus b. So its slope is -b over a.
Set -b over a equal to -2. Because a and b are positive, that means b over a equals 2 or b equals 2a.
The same triangle has base and height b, so 1/2 of b equals 36. Substitute b equals 2a, the 1/2 and the 2 cancel, leaving a squared equals 36.
Since a is a positive intercept, a equals 6, then b equals 2a, so b equals 12. Intercept form reaches the same answer without first writing b over 2.
The first method names the y-intercept directly in slope-intercept form. The second method treats both intercepts symmetrically. Choose whichever representation makes the relationships easiest to see.
One tempting wrong answer is 6. That is a real coordinate, but it is the x-intercept. The question asks for the y-coordinate of the y-intercept, which is the taller leg, 12.
Another trap is -12. It solves the squared equation, but it contradicts the positive intercept condition. Algebraic solutions must always be filtered through the geometry and the wording.
A third mistake is forgetting the 1/2 in the triangle area formula. That would double the relationship between the legs and the area, producing a value that fails the direct area check.
Also notice that the prompt asks for a coordinate, not the area, not the slope, and not an ordered pair. On the SAT, answer exactly the quantity requested after all the modeling is complete.
Let us generalize. Suppose the slope is -m, where m is positive, and the y-intercept is b. Setting y equal to 0 gives an x-intercept of b over m.
The coordinate triangle area is then 1/2 times b over m times b. That simplifies to b squared over 2m.
Solving that relationship for a positive y-intercept gives b equals the positive square root of 2ma for our problem. M is 2 and a is 36.
2 times 2 times 36 is 144, and its positive square root is 12. The general formula compresses our entire derivation, but the derivation explains why the formula works.
Try a new one. A line has slope -3, positive intercepts, and forms a coordinate triangle of area 24. Pause and find the y-intercept before Sol checks it.
Use b equals the square root of 2ma. 2 times 3 times 24 is 144, so b equals 12. The x-intercept is b over 3, which is 4.
The check is 1/2 times 4 times 12, which equals 24, and the slope from 0,12 to 4,0 is -12 over 4, or -3.
The reusable idea is not merely a formula. Slope fixes the ratio of the vertical and horizontal intercepts, while area fixes their product. A ratio and a product together determine both positive lengths.
My checklist is simple. Name one intercept, use slope to express the other, put both into 1/2 base times height, solve, and then use the sign condition before reporting the requested coordinate.
For this exact problem, y equals -2x plus b gives an x-intercept of b over 2. The area equation becomes b squared over 4 equals 36, so the positive intercept is 12.
Because this is a student-produced response, enter 12. Do not enter 6, an ordered pair, or the negative root. The requested y-coordinate is 12.
Slope -2, intercepts 6 and 12, and area 36 all agree. The final answer is 12.
Optional SAT math study resources are linked in the description. If you purchase through an affiliate link, the channel may earn a small commission at no extra cost to you. As an Amazon associate, I earn from qualifying purchases.